Hi, I'm Kathy Levinger. In this lesson we're going to look at linear inequalities. Let's start with a little bit of the language of inequalities and the symbols. Here's what we want to do. We want to translate each statement written in words into symbols and each statement written in symbols into words. And the first statement here is written in words. It says 3 more than some number is at least 5. 3 more than some number can be written 3 plus, and now choose a variable for some number. The is at least 5 part of the statement is where an inequality comes in. To be at least 5, 3 more than some number needs to be bigger than or equal to 5. And you'll see a lot of hints about phrases like at least in your textbook on page 29. In part B here, we see a statement written in symbols. It says y minus 10 is less than 2, and what I just said could be exactly how you might write this statement. Or you could write something like 10 less than y, which is what this side represents. Some amount 10 less than y is less than 2, might be a way to finish out the statement here, is less than 2. Again, look at page 29 in your book for some more hints on how to write symbols in words and words in symbols. And let's move on to solving inequalities and checking them. Here's a linear inequality. What we're going to do is solve it and check our solution set. When you solve a linear inequality, you're going to solve it similar to how you would solve an equation, with the exception or the additional rule that if you need to divide or multiply both sides of the inequality by a negative number, the direction of the inequality symbol changes. Just to emphasize that rule, we'll come back and solve this inequality in a minute. Notice that if you had an inequality that you know is true, like 5 is less than 6, you know that that's true. Suppose I take the number 5 and the number 6 and multiply each of them by the same negative number. Let's pick arbitrarily the number negative 2. Well, 5 times negative 2 is the number negative 10, and 6 times negative 2 is the number negative 12. And as far as which one's bigger or which one's smaller, I know that negative 10 is greater than negative 12. The point of this is to emphasize that if you take an inequality and multiply each side of it by the same negative number, the direction of the inequality changes. So keep that rule in mind, and let's solve some inequalities. This one is 5 times 2 minus y is greater than or equal to 15. We need to start by distributing. 5 times 2 is 10, minus 5 times y is 5y is greater than or equal to 15. To isolate y, I'm going to subtract 10 from each side of the inequality. That leaves me negative 5y on the left is greater than or equal to 5 on the right. To get y by itself and solve the inequality, I need to divide each side by negative 5. At the instant that I do that division, the direction of the inequality changes. It changed from greater than or equal to less than or equal to. Simplifying each side, I see that the solution to the inequality is y is less than or equal to 5 divided by negative 5, which is negative 1. Now this is a solution set, a set of numbers. All the numbers less than or equal to negative 1 work in this inequality. To check our solution set, we need to check 2 things. We need to check the boundary point, which is actually the number negative 1, and we need to check the direction of the inequality. So what I'm going to do is rewrite our inequality and solution set, and we're going to check. First we'll check the boundary point. That's the number -1. Let me write what we're going to do here. Check boundary. -1 is the number that would make this an equality, or would make this true if it were an equality. So I'll put -1 for y and a question mark here. And what we want to do is determine whether -1 actually makes this an equality, an equation, a true statement. Simplifying the left-hand side, this is 5 times 2 minus -1 is 3. 5 times 3 is 15, which does equal 15. So the boundary checks. -1 is the number that would make this, if it were an equation, true. It gives us equality for the left-hand side and the right-hand side. The second thing we need to check is we need to check the direction of the inequality. The direction means we want to check that the numbers that can be substituted for y that are less than or equal to -1 are actually the numbers that make this a true statement. So let's pick a number that we know is less than or equal to -1, like -2. Let's take the number -2. Let me say what we're going to do is we're going to substitute -2 for y and see if it works in the inequality. Let's put -2 in there. 5 times 2 minus -2, is that, I should say question mark, greater than or equal to 15? We want to know, is that actually greater than or equal to 15? In which case our direction would check. Continuing to simplify, this is 5 times 4. Is that greater than or equal to 15? Well, that's 20, which is greater than or equal to 15, and so our direction checks. These two procedures are necessary to confirm or check that y less than or equal to -1 is the solution set to the inequality. Let's try another. What we want to do is solve this linear inequality. We're going to check our solution set, and then we're going to also write the solution set in interval notation and then graph it on a number line. But let's worry about these first two things first. Solving this inequality, treat it as if it's an equation by distributing first. So we'll do 8 times 2, which is 16t, plus 8 times 5, which is 40, is less than or equal to 4 times t minus 4 times 2, which is 8. Let me, at this point, subtract 4t from each side to get 12t plus 40 is less than or equal to -8, which is all that remains on this side. Now I'm going to subtract 40 from each side of the inequality. That'll leave me with 12t on the left-hand side and -48 on the right-hand side. As a final step, I'm going to divide by positive 12. I'm dividing by a positive number so I don't change the direction of the inequality. And I get the solution set t is less than or equal to -48 divided by 12, which is -4. So there's our solution set. Now we're going to check it. Let's rewrite our inequality. 8 times 2t plus 5 less than or equal to 4 times t minus 2, and our solution set, and perform our check. We'll start with the boundary check, which means we want to put -4 into each side and see if it makes this an equality. 8 times 2 times -4 plus 5. How is that related to 4 times -4 minus 2? Performing or simplifying the left using order of operations, we'll start with 2 times -4, then simplify in parentheses, and then multiply 8 times negative 3. And let's see how that compares with the right-hand side. This is 4 times negative 4 minus 2, which is 4 times negative 6 is negative 24. So the boundary checks. Now we need to check the direction. Our solution set is numbers t that are less than or equal to negative 4. So let's pick a number that we know is less than or equal to negative 4, like negative 5, and see if negative 5 checks. That's what we want to determine. So let's put negative 5 for t in each side of the inequality. And we want to know, is that less than or equal to 4 times negative 5 minus 2? Starting with the left-hand side, we have 8 times negative 10 plus 5, which is 8 times negative 5, or negative 40. Is that less than or equal to 4 times negative 7, which simplifies to negative 28? Now negative 40 is less than or equal to negative 28, so the direction checks. Now there's another little bit to this example, and that was to take our solution set and write it in interval notation. There's a lot of descriptions of interval notation on page 31 in your textbook. This particular interval to indicate all numbers less than or equal to negative 4. We use a parenthesis symbol and then negative infinity with a comma, the number negative 4, and a bracket. Recall that a bracket is used when the equal to part of the inequality is included in the solution set. This negative infinity symbol is to indicate all numbers less than or equal to negative 4. And so here's our interval notation form of our solution set. On a number line, let's put 0 a little bit to the right, and then negative 1, negative 2, negative 3, negative 4. Let's put negative 2 in the middle, so you know that these tick marks are 1 unit. We translate what we've written in interval notation to the number line by putting a bracket at the number negative 4, and inside that, actually I should indicate that the bracket opens to the left in the direction of numbers less than or equal to negative 4. And then inside the bracket, put in a darkened arrow to point, or that points in the direction of numbers less than or equal to negative 4. And so there's a graph of our solution set. Let's try another example, this one involving fractions. With the same directions, here's the inequality we want to solve. As far as solving this particular one, I see that the common denominator, or the least common denominator actually, is 12. I'm going to start by clearing the fractions, multiplying every part of the equation by 12. So I'll take 12 times this first term, negative 7 over 12x, that's a 7, plus 12 times 1/2, the next term, greater than 12 times negative 3 over 4x. Now this 12 I'll consider over 1, and I'll use it to simplify all the fractions. The first term then, once the factor of 12 has simplified, is negative 7 over 1x. In the next term I can simplify a factor of 2 and get 6 over 1, or 6. And on the right hand side, simplify a factor of 4. 3 times negative 3 is negative 9x. The negative 9 is over 1. To continue solving, I'm going to add 7x to each side to get 6 is greater than negative 2x. And finally, to isolate x, I need to divide each side of the inequality by negative 2. Now to give myself a little bit of room, I'll move over to the right a little. But at the instant when I divide by negative 2, I'm going to change the direction of my inequality. 6 divided by 2 is negative 3, And so my solution set is reading from the right-hand side, x is bigger than -3, or I could read from the left, -3 is less than x. Okay, let's perform our check. So let me rewrite the inequality, -7/12x plus 1/2 greater than -3/4x. And our solution set, -3 is less than x. We start with the boundary check, which means we take -3 and put it for each x in this inequality. -7/12 times -3, which I'm going to consider over 1, plus 1/2, is that equal to -3/4 times -3/1? Well, back to the left-hand side, I see that a factor of 3 will simplify. -7 times -1 is 7/4 plus 1/2. I need a common denominator, so I'll multiply the second fraction by 2/2. So I have 7/4 plus 2/4, which is 9/4. Well, let's see what we get on the right-hand side. -3 times -3 is 9/4, and so I do have a boundary check. So let me indicate that the boundary checks. Now we need to check the direction of the inequality. We need to pick a number, actually I should say direction of the solution set. Pick a number that's in the solution set, which means pick a number for x that is bigger than -3. Something bigger than -3 is the number -2. So let's check the number -2. Putting -2 in this inequality, we're going to find -7/12 times -2/1 plus 1/2, and we want to know if that's bigger than -3/4 times -2/1. Again, simplifying here when we multiply the fractions, but simplifying a factor of 2, I get 7/6. I need to add 1/2. The common denominator is 6. So multiply this 1/2 by 3/3. So we take 7/6 and add 3/6, which gives us 10, not 9/6, which reduces to, let's see, 5/3. So this side simplifies to 5/3. Now I want to know if that's greater than what I get on this side. I can simplify here a factor of 2, which gives me -3 times -1, or 3/2. And so what I actually need to know is 5/3 bigger than 3/2? At this point, you have a couple of different options. 3/2 I know is 1/2. Let me consider that 3/2 is 1/2. 5/3 I know, if I make it a mixed number, is 1 2/3. Well, 2/3 is bigger than 1/2, and so we do have a direction check. Our direction does check. Direction checks. And now, finishing out this problem, we need to take the solution set and write it in interval notation and graph it on a number line. So let me rewrite my solution set here. In interval notation, the smallest item in my solution set is the number -3, but I use parentheses and -3 on the left, not a bracket, because there's no equal to attached to the inequality. To the right of that, I use an infinity symbol with parentheses to indicate all the numbers in my solution set are all the numbers bigger than -3. Now this translates very well to a number line. Let me put 0 a little bit to the right. 1, 2, 3. Here's -3 on our number line. I want to indicate that -3 is the left endpoint with a parentheses, because I'm not allowed to include -3 in my solution set. And then pointing to the right in the direction of things bigger than -3, I draw an arrow to indicate everything greater than -3. Well, be sure to work lots of exercises from this section for practice.